when I'm sick and have a headache or a cold, this is what I take. Wait, but wait, please note, I'm not a doctor. So this is medicine people take it when they have a headache. But if you're, yes, no, but you can buy this in Spar. Yes. Oh, it's, I mean, there's many different companies. You know this medicine? But it has many different companies. See, like this. This is one company in Ireland. It has lemon in it. Yeah, this is the name of it. It's not expensive. It's only like €2. It doesn't matter which company. You just ask for this. Yeah. But remember, I'm not a doctor. So what I mean is, I don't know if you're allergic to medicine. Some people can't take some medicine. Are you allergic to any medicine? That means you can't have the medicine. What's allergic? Do you know allergic?
Allergic?
No, you don't.
Spelling. Which doesn't suit you, some medicines.
Yeah, you take it, but it makes you sick. You can't take it. What's this? You know what I mean?
Maybe.
Like, you know, some people can't take milk because they take milk, they get sick.
Yeah.
You know the word?
Yeah.
So some medicines people can't take. Can you take any medicine? Okay.
20%.
It doesn't matter. Do you need to go to the shop now to get it? Huh? You don't want to move? Stay somewhere safe and warm.
And also,
Yes.
no teacher.
Yes. Yes. Well, look, Grace, if you're sick, maybe you should go home.
No.
Because you can watch the videos at home.
But I'm here now.
True, you are here now.
And have big headache because from last night. And I have blackout. And I maybe at 2 o'clock and can't sleep. And this morning I take the bus. The bus keeps taking, and I was.
I understand. Yes, this is the problem when you live in Ireland. Cold weather, shaky bus, not good. Not good. Well, I hope you feel better, but if you need to go home, you should go home if you're sick. And the physics lessons will be uploaded tonight, like normal. So just remember that, okay? Right. Yeah, no, you won't blow up, okay? You might be sick, but you won't blow up. Okay, so 0.82 and 35. So you have your pendulum. Its length is 0.82. And its amplitude as it swings is 0.035 meters. Part A. What is the time? Easy peasy. What's the formula? Lemon squeezy. 2 pi root L over G. So did you get an answer, Amanda? Or Grace?
I use different.
Oh my goodness. What formula did you use?
2 pi over omega.
But I didn't tell you the omega.
Amplitude. Amplitude. It's not omega?
No.
No?
It's not.
What is
This is amplitude.
which A?
Yeah.
My God.
Yes, indeed. Right. So the time is 1.817 seconds. B. What is the maximum velocity? Now this one's a little tricky. What's the formula for velocity if it's simple harmonic motion? Well, it's, let me get this right, A omega sine omega t. Yeah?
Yeah.
But I don't want the velocity, I want the maximum velocity. Does the A change?
No.
No. Does the omega change?
No.
No. Can the sine change?
Yeah.
What's the biggest value sine can be?
1/2. 1.
1.
1. Oh.
Yeah. So what's the biggest V can be? A omega. Very good. Do you know the omega? No. But you know that omega is 2 pi over t. So now you can know it. C. Where will this happen? Where is the ball going fastest?
Middle.
The middle, yeah, when it's down here. This is when it's going fastest. It's fastest at the lowest point.
But even
Yeah.
if it's in the middle, it should be Gauss.
Yeah, but it starts at the end.
Oh.
So that is sine for the B. D. What is the maximum acceleration? So again, you can use the formula acceleration equals minus A omega squared sine. Yeah?
The question D.
Yeah.
D equal A omega sine omega t.
Yeah.
Does only omega t is in
In the sine?
the side, or does only omega?
Oh no, omega t together is in the sine. Yeah. Okay, so what is the maximum acceleration? Yeah, A omega squared. So that means we get omega, where's my omega gone? Oh, I don't have omega. It's 2 pi over t. A omega squared. It is 0.419 meters per second squared. Okay. Next. Where is the acceleration maximum? What does Newton say about force? F equals ma. So when acceleration is maximum, force is maximum. When you have a spring, when is the force maximum? In the center? No. When the spring is fully stretched or fully compressed. So the acceleration is maximum here or here is maximum force. I mean, think about it.
In the
Yeah.
middle, the length is the.
Oh, but in the middle, there is no force in the middle.
It's not. But the point is goes up, not go the left or the right.
No, it's going left and right. Now I know it is going up and down a little bit, but we imagine it's only going left and right. Like this. I know it's going like this, but we imagine it's only going like this.
Or in a straight line.
Yeah, to make the calculation easier. I know it's not really doing this. So anyways, the answer for E is at the highest point. Okay. F. Sketch the energy graph. Do you remember what the graph looks like?
Yeah, it's like that and like that.
Hold on a second there. This is energy and this is displacement in meters and the energy in joules. So at the beginning, what's the kinetic energy? Zero. And then what happens to it? Increases. So the kinetic energy goes like this. The potential energy? The other way. At the beginning it's maximum, then it decreases like that and increases. So that's potential energy. And then finally the total energy stays the same. Total energy. But I gave you this graph already. You remember it?
Yeah.
Yeah. So you can check your notes for that. G. What is the total energy if its mass is 45 grams? Now here's the little trick here. The energy at the top is the same as the energy at the bottom. Up here it has only potential energy. Do we have a formula? We do. It's a half m omega squared whatever. But we don't need to use that because the potential energy here is the same as the kinetic energy here. And we know the velocity here. That was the answer to question number that should say meters per second. Part B. So the total energy equals the potential energy at the top, or it equals the kinetic energy at the bottom.
In the middle, just maybe it's only P.
In the middle, it's only kinetic.
Why? It's just here, the weight and the height.
But look here, we imagine like it's on the ground.
It's not moving.
Yeah, it's moving like this.
That's the.
It's like a spring going left, right, like the train. Left, right, left, right. In the middle, there's no potential energy.
But why in the beginning is only potential energy?
Because it's not moving at the beginning. It's at rest.
Just rest.
Yeah.
So
it's at rest.
It's not PE, no KE.
Say again?
No energy. You say it's not energy. So
no kinetic energy at the
okay.
beginning.
They have potential
Yes.
energy?
Yes.
Why?
Why?
Yeah.
If I have a spring
Yeah.
and I pull the spring, what will happen if I let go? It will move. So that it must have potential energy because when I let go, it becomes kinetic energy. So with the pendulum, when I pull it up, it must have potential energy because when I let go, it becomes kinetic energy. You know?
So only this the pendulum. Only pendulum has the PU on side, from side.
Oh, I see what you mean. No, I mean if you had something like this,
Just this question is.
he has potential energy at the start, and then he'll have kinetic energy at the end. Yeah. Yeah. And sometimes, Amanda, you might have it like this, where there's kinetic energy here, and then it becomes potential energy here.
So how can you define which part is KE and PE? Because is different.
KE is the part that's moving.
Yeah.
And usually the potential energy is not moving. Yeah, like usually. So like here he's not moving and then he falls. So his potential energy is mgh. Maybe? Okay. Anyways, this is equal to a half mv squared, which is a half 0.045, 0.121 squared. Did I say it was 121 earlier, the velocity?
0.419. Oh yeah, that's the other you just 0.1218.
Okay. So that is 3.29 times 10 to the minus 4 joules. Yep. Okay, next part, H. What is the length of the pendulum if its frequency is 0.75? Okay, so frequency equals 0.75. What's the time? 1 over 0.75, which equals 1.34 seconds. But t equals 2 pi root L over G. So that means 1.34 equals 2 pi root L over G. And solve it for L. So I get here L equals 0.446 meters.
How would you get L?
How did I get L? Good question.
How to open the...
How to open, yes? I'll show you. Let me rewind. So what I did, great, I square.
Can I hit you?
No, really? I don't know.
I understand.
I can stop? Okay, so then, what did I say the L was? 0 point something?
0.446.
0.446 meters. Okay, next. No,
Oh my god.
2 left.
It's a whole ABC.
So, if I change the density here, you remember density?
Yes.
And I make the density twice as big, what happens to the time?
Time?
The time.
More, a little bit shorter?
Because it's heavier, it's
Yeah.
going faster?
Yeah.
Yeah? No.
But time doesn't depend on that.
That's it.
So it should be the same.
The same?
Yeah.
Is there an m in this formula?
No.
Is there a density?
No.
No.
So it doesn't matter. The time's the same. And finally, J. What would happen to the time if I change the amplitude?
No. It will be same.
Yeah, the time is the same. T the same. Because there's no amplitude in this formula. So even if the amplitude was 0.035 over 2, so what? You don't put it into this formula. So the T is still the same. So the time only depends on what?
Length.
Length, and that is all.
Can we have a 5-minute break?
Thank you.
No, wait. Just let me do the other homework and then we can take a break. Because it's quite short, the charge and current, okay?
Yeah.
Right.
Should we take this into...
No, you can just say the T is the same for I and for J.
Oh. And...
Because the formula only cares about the L. It doesn't care about these things. So the time is the same. Okay,